Let's look at the Common Core standard from grade 4. It's part of Extend Understanding of Fraction Equivalence and Ordering. Explain why a fraction a over b is equivalent to a fraction n times a over n times b by using visual fraction models, with attention to how the number and size of the parts differ even though the two fractions themselves are the same size. Use this principle to recognize and generate equivalent fractions. Now this one is a little hard to understand, primarily because of the variables that are used. So I think the main thing to clarify would be, what happens with n times a over n times b, and also this additional idea of the two fractions themselves being the same size even though the number and size of the parts differ. So let's look at these pieces here to clarify what the standard is really getting to. If we take the expression and try to make some sense out of it, let's rewrite it to where we have this in the form where it's vertical, and it still doesn't make a whole lot of sense. So let's keep going, and let's split that up into two fractions. Now it's starting to get a little bit more clear, because now what you really have equal to, since n over n represents some number divided by itself, that's always going to be equal to 1. So by getting to this point, it should be a little bit more clear that here's the reason why there's no actual change, why they would be equivalent fractions when you multiply by n over n, because you're really multiplying by 1. So then you do have a over b still equal to itself. So let's take a visual model, and let's suppose that we have 2/3 as our fraction. And so we take our 2/3 and we split up our rectangular model here. Now let's suppose that the n over n is 3 over 3. So this is what happens to your visual model. We're going to take each of those 1/3 and split them up into 3 additional pieces each, so that now what we have is a total of 6 smaller pieces, but it's still equivalent to the original 2 larger ones. So we have 6 pieces, and then as far as the total, that would be out of a total of 9. Okay, let's go ahead and take another situation and continue to make some sense out of this. Let's go with a circular model this time. And let's suppose that our fraction is 3 over 4. And this time, let's let our n over n, let's say it's 2 over 2. So now what we have is 1, 2, 3, 4, 5, 6 pieces. But again, notice that nothing changed. I still have the same whole, and even though I've chopped it up into more pieces, I now have 6. It's still the same size out of now a total of 8 pieces. So the 6/8 is still equivalent to the original 3 over 4. But again, notice what we're doing with the 2 over 2 in this case is we're cutting up each of the original 3 pieces into smaller ones. Now we can also use a distance model for this. Okay, let's rewrite this to where it makes a little bit more sense. So now let's let our original fraction be 2 over 3 again, but this time we're using a number line. So now what we're dealing with is 2/3 of the distance from 0 to 1. Now let's go ahead and let our n over n be 2 over 2. So again, what happens is that each of those 2 pieces is divided up into 2 smaller ones, so that now we have a total of 4 out of the original, well, now 6 pieces. So again, it's still the same distance, but it's still equivalent It'd be sort of like if you divided something up into feet and then you split those up into inches, but you're still dealing with the same distance.